Okay, let's talk about constitutive laws. So let me put a title in here. We're going to go constitutive laws, or also they are called constitutive equations. Okay, what are these? All right. So what we're going to do is we will have this, as you can see in here, we're going to begin looking at, this is the topic, but let's look at the elements. For example, if I look at the R element, let's do a mechanical R element, and let's say that you have this this kind of element in there. So this is, let's do a mechanical element, and you have this, let's do an electrical one. Okay, an electrical, you're gonna have this kind. This is we're gonna do first the R element. So this is called the R element, and then you're gonna have, this is the perhaps we'll do a hydraulic element. Okay, on this, what kind of element can we draw for a hydraulic system? Let's say you have a tank and you have a valve over here. This is going to be your R element in here. Yeah. So these are the physical elements. Why don't we're going to make a table in here. We're going to go, it's going to go in here, we say physical element, so the real element, yeah. Okay, this we are going to use we're going to write down in here the laws as we use this, and for this purpose, in here you could say we're going to put this force over here like this, and we say that the force is equal to B times x dot, like that, right? This is the equation, normal equation of this element. If this is a element that is there is a voltage across these two elements, like it is in a circuit or so, then you have that voltage of the R element, or V, is equal to the current I times the resistor. So in here is the current I, and of course the value of the resistor. In this particular case, the variable is pressure here. So the pressure here, or the difference in pressure, is equal to the coefficient. Usually people use Cp times the volume flow rate. So these three are the equations that control the behavior of this, normal equations. Now we have we have to define these equations that describe the behavior of this as constitutive equations. These are the constitutive laws. These are the how do we call it? Maybe we call it the yeah, let me say constitutive law. Okay, but you see in here we need to relate this to the block diagram we need to relate this to the bond graph notation, and then ultimately we need to relate it to a bond graph little picture in there. So in here, if you write the block diagram, which is the more logical step in this case, you could say that this is x dot, and you come in here and then you multiply this by the value of b, and out of this comes f, see, like that. So this would be the block diagram of this equation. One thing that I hope to convince you from the beginning is that you cannot do the block diagrams unless you have these equations. Block diagrams represent equations. So in here you could also have as an input the current I, and then of course you have the resistor in here, and then you will have this from here you will have the output B sub R. For this one you'll do the same thing, but you see what happened is that the element is not changing. What is changing are the units, and this comes B like this. So this is the block diagram of the element. Okay. What we have done in going to the bond graph notation is basically to simplify the notation in here. If this is the output of this, you can see the output is the one on the left hand side of the equation, right? That's how you define. That's the variable that gets calculated. So if we represent this in a bond graph sense, you would have that the R element is the output is, well, I'm going to change colors to make it pretty and make it meaningful here. And the output, in fact, in this case is F, and then the input to this is X dot. Do you see how you read this thing? This is the input to this R element, but what is away from the R is the output F. So all these things are totally equivalent to what I have just done. So in here we can do for this one over here the same way, and let's just put it again. Make sure that you put in here the output of this is going to be this voltage, and the input of this is the current, see? And let's just do it for the other element in the hydraulic domain also. This is the R, and this is in here you have the wait a second, let's just be consistent with this. So I am going to use the R element like this, and in here you're gonna have the output of this is going to be like this, and the output in this case is the pressure, but the input is this Q. Right? So this is your bond graph. Okay, this is your bond graph. So we have the equation here, we have the block diagram, we have the bond graph in here. What we have done to this bond graph notation is to make it a universal notation. For we write like this, and so that it's totally consistent. Instead of writing F, we write E, and instead of writing X dot, we write F for flow. This other one in here on this side, let's change colors here. This one over here, this R, and you have it like this. This we are going to call it also E, and this is going to be F. And for the other one in here, this R, and we are going to do this red element in here. Okay, red in here. This one here, this is E, and this is also F. So do you see what happened? For the bond graph notation, all these three look the same, but the units are very different in each one of those. So, but the constitutive law, the form of the constitutive law, does not change. Okay, so we write like this. The law for this is that E is equal to R times F. For this one, we also law E is equal to R times F. And then finally, we say E is equal to R times F. Okay, so this is the bond graph, and I would call it on this side, I would call the bond graph, let's call it generalized notation. Okay, bond graph generalized notation. Now, this is the you have seen the block diagram in here. You have seen the bond graph. You see the constitutive law. You have the physical elements. Now, let me pose this challenge to you. Let's just write the original constitutive law. The law was that F is equal to R times X dot. But now what I'm going to do is I am going to write it. It says if we write now that X dot is equal to 1 over R times F. So this is another form of the same law, but just written in a little different way that we had in the past. I mean, I could do the same thing for this one. I could write it in here that the current I in this case is equal to 1 over R times V. And this one in here, we can write that Q is equal to 1 over C sub P times the pressure, right? So this is, why don't we call it here another form of the law. What are the consequences for the block diagrams or for the bond graphs? In particularly, I am interested that you grasp the concept of what changes on the bond graph model. So let's do that first. In this case, let's see, this is the bond graph like this. You see the output of this is now this X dot. So that suggests that the input is F or E. So you see what happened? And this is F now, this is X dot. If we generalize this notation, we know now that F in this case is 1 over R times E. And that's exactly what we would do with the R element in this different form of the constitutive law. So in here you have that this is R, and then you have also that the input of this is like this. The output then is I, and then this is V. In here, how about I put it in the parentheses E, and then in parentheses here this is F. So I don't have to draw another bond graph on this. But I think by now you know exactly what I'm trying to do. I think in this case we are writing the bond graph models, we're writing the R element in different ways. So in here you have the output of this would be Q, and of course the input on this is going to be P, see, like that. So the constitutive law for this one is going to be that this is this is going to be I, or is equal to 1 over R. Well, I already did over here, see. So but this one is the idea is that now F is equal to 1 over CP times the effort variable, or we call it CP, we call it R, you know, like that. So that's the situation. So I am going to I have shown you now what is the constitutive law for the R element in all these dimensions, in all the forms, whether it's this one, the law itself, then this is the block diagram, and this is the bond graph model, this is the generalized notation. And if we switch the law around, we also switch around the representation of the bond graph model. Okay, so that's the explanation of the constitutive law of the R element.